So hello everyone. Today we see some more problems in equilibrium. Okay, these are somewhat different compared to the last classes. Okay, see the 1.38 grams of N2O4 was placed in a 1 liter reaction vessel at 400 Kelvin. So and allowed to, at equilibrium, allowed to form an equilibrium of this. So the total pressure at equilibrium was found to be 9.15 bar. So calculate the Kc Kv. So ఇక్కడ ఇచ్చిన క్లూ మనకి in terms of pressure కాబట్టి at first we are able to find the Kp. So then with the help of Kp Kc relation we can find the Kc. First we find the Kp. So Kp find out చేయాలంటే ఫస్ట్ మనకి ఇనిషియల్ ప్రెషర్ తెలవాలి. సో నార్మల్గా కాన్సన్ట్రేషన్స్లో ఇస్తే ఇనిషియల్ కాన్సన్ట్రేషన్ తీసుకుంటాం. తర్వాత మైనస్ ఎక్స్ ఫార్మేషన్ ఆఫ్ ఎక్స్లో మనకి ఈక్విలిబ్రియం కాన్సన్ట్రేషన్ చెక్ చేస్తాం. బట్ ఇక్కడ ఇనీషియల్ ప్రెషర్, సో ఫైనల్ ప్రెషర్ తెలవాలంటే అసలు ఇనీషియల్ ఈక్విలిబ్రియం ప్రెషర్ ఫైండ్ అవుట్ చేయాలంటే ఇనీషియల్ ప్రెషర్ తెలవాలి. సో ఇనీషియల్ ప్రెషర్ ఈజ్ నాట్ ఎగ్జాక్ట్లీ గివెన్. సో ఇనీషియల్ ప్రెషర్ ఇవ్వలేదు కాబట్టి we will find the information is given 1.38 weight, that's 1 liter. So and temperature is also given. So with the help of these values, by using ideal gas equation, PV is equal nRT, so we are able to find the initial pressure, initial number of moles how much, so weight by, so what is the molecular weight of N2O4? N2O4 means what is the molecular weight? So 28, okay, so 92. What is R value? We know that is 0.0821. So actually 0.0821 atmosphere liter per mole per Kelvin. So atmosphere ke bars ki there is not a big change, just 0.001 only difference. So kabatti direct ga bar ichina kuda 0.0821 తీసుకుందాం. What is the temperature directly given? 400 Kelvin. So just on this calculation, so it is 1.38, so it become okay 8.21 to 4. So on overall this calculation we will get the pressure is approximately 4.98 bar. Okay, so this is the initial pressure because on this details initial details kabatti ikkada reactant pressure is also initial pressure. So initial pressure base cheskoni we have to find the equilibrium pressure. So you got this one. So again we can write N2O4 gives rise to NO2. So what is the initial pressure? So initial values to మనం find out చేస్తాం కాబట్టి it is the initial pressure. Initial pressure 4.98 bar. So here there is no products are there at initial. But what is at equilibrium? So at equilibrium just say 4.98. So minus x bar, this we are taking as a minus x bar. So in terms of concentration అయితే x concentration తీసుకుంటాం, ఇక్కడ pressure కాబట్టి x bar తీసుకుందాం, x bar here x, but here how many moles? 1 mole కాబట్టి 1x, here 2 moles కాబట్టి 2x. So next, so what is the final pressure? So final pressure is given how much? In the problem itself it is given the pressure at equilibrium. So మనం ఇంతకుముందు ఫైండ్ అవుట్ చేసింది ఏంటంటే ఇనిషియల్ ప్రెషర్. సో అట్ ఈక్విలిబ్రియం ప్రెషర్ ఇట్ వాస్ గివెన్ దట్ ఈస్ 9.15 bar. సో equilibrium pressure given is 9.15 bar. So therefore now we can write, so with the help of this we are able to write సో మనకి ఇండివిజువల్ ప్రెజర్స్ అంటే ఏంటిది పార్షియల్ ప్రెజర్స్. ఇప్పుడు ఆ మిక్చర్లో ఆ ఈక్విలిబ్రియం దగ్గర ఇన్ ద రియాక్షన్ మిక్చర్ 2x బార్ 2x బార్ ప్రెషర్ ఎక్సర్ట్ చేసే నైట్రోజన్ డయాక్సైడ్ ఉంది, 4.98 మైనస్ ఎక్స్ ప్రెషర్ ఎక్సర్ట్ చేసే N2O4 ఉంది. Means in that reaction mixture two compounds are present, two compounds are separately giving how much pressures, 2x pressure and 4.98 minus x pressure. So according to Dalton's law, we know that the mixture of gases, the pressure exerted by the mixture of gases is exactly equal to the sum of partial pressures. So కాబట్టి ఇక్కడ టోటల్ ప్రెషర్ ఈక్వల్ టు ఏం రాసుకున్నాం, సమ్ ఆఫ్ పార్షియల్ ప్రెషర్స్. సో అంటే ఇప్పుడు పీ టోటల్ ఈక్వల్ టు ఇక్కడ 2 గ్యాసెస్ కాబట్టి సో P1 ప్లస్ P2. అంటే ఇక్కడ ఉన్న 2 గ్యాసెస్ ఏంటి మనకి N2O4 and NO2. What is the total pressure? Therefore 9.15 equal to, we can write 4.98 minus x plus 2x. So since with the help of Dalton's law, we applied Dalton's law here, okay. So 9.15 equal 4.98 minus x to x, here we will get plus x, and therefore so here we get x equal to and finally x equal 4.17 bar. So this is x. So is it not the partial pressure? It is not the total pressure. Just it is the pressure decrease in the reactant, pressure increase in the products. Okay. So with the help of x, now we are able to calculate these partial pressures. Okay. So therefore the partial pressure of N2O4, individual pressures are nothing but treated as a partial pressure. So P(N2O4) at equilibrium we are calculating is 4.98 minus x equal to 4.98 minus how much you got, 4.17. Okay, that is a 0.81 bar. Means the partial pressure of N2O4 at equilibrium. So and the partial pressure of NO2 equal what? 2x. So 2 into 4.17. Already just we calculated the x. That is 8.34 bar. So now apply into Kp. Okay, already we know the Kp relation. What is that? So Kp equal to in terms of pressure kabatti partial pressure of NO2, how many moles? 2 moles square by partial pressure of N2O4, so 1 mole kabatti no problem. So NO2 square means it is 8.34 into 8.34 by what is the P(N2O4), that is 0.81. So on this overall calculation we will get 85.87. So try to check the calculation. 85.87 bar. So here bar cancel, 1 bar will be there. So 85.87, it is a Kp value. And we know that we have to calculate Kc also. So how to get Kc? We know the relation Kp equal to Kc RT power delta N. So RT power delta N, so Kp is 85.87. I have to find the Kc, R value 0.0821. Temperature 400. What is the delta N? Delta N. So what is delta N? So delta N is the change in the number of moles of product and reactants which are present in gaseous states. here 2 inward 2 unde 1 inward, there is just 2 minus 1 unde. So therefore Kc is equal to 85.87 by, so on overall calculation we will get 2.586. Okay, these are the Kc Kp values calculation. So just what is the difference in the last problems and these problems, and just it is given in terms of pressures. Okay, see the next one. So the value of Kc for H2 plus I2 gives 2Hi, means the formation of Hi reaction, the Kc is given 64 at 773 Kelvin. We know that equilibrium constant value mainly depends only on temperature. So that's why they mentioned about the temperature always. So if 1 mole of hydrogen, 1 mole of iodine and 3 moles of Hi, means at general initial position లో మన product 0 moles తీసుకుంటాం, but in this it is separately given 1 mole of H2, 1 mole of I2 and 3 moles of product, 3 moles of Hi are all mixed in a 1 liter flask. So this 1 liter కాబట్టి it is no problem in the calculating the concentration. So find the concentration of I2 and Hi at equilibrium. So normal గా బిఫోర్ ద రియాక్షన్ అయితే మనం డైరెక్ట్గా క్యాలిక్యులేట్ చేయొచ్చు కాన్సన్ట్రేషన్ మోల్స్ పర్ లీటర్, అంటే ఇక్కడ నెంబర్ ఆఫ్ మోల్స్ 1 పర్ లీటర్ 1/1 ఇట్స్ కాన్సన్ట్రేషన్ 3/1. సో అది బిఫోర్ ద రియాక్షన్. సో మిక్స్ చేసిన తర్వాత ఈక్విలిబ్రియం ఫామ్ అయిన దగ్గర మనం వీటి కాన్సన్ట్రేషన్ ఫైండ్ అవుట్ చేయాలి. So we know the initial condition. So generally initial reactants rastam, product 0 rastam. But here initial it is given it is 1 mole, it is 1 mole, it is 3 moles. Okay. Next, at equilibrium, what are the changes we have to take in terms of x? Because there is no percentages, there is no other clue is given. But in terms of x తీసుకుంటాం. So actually ఇక్కడ మనకి అంటే క్లూ ఇచ్చిన ఫస్ట్ ఇన్ టర్మ్స్ ఆఫ్ ఎక్స్ రాసుకున్న తర్వాత సో ఆ ఎక్స్ను విత్ హెల్ప్ ఆఫ్ పర్సెంటేజ్తో ఫైండ్ అవుట్ చేస్తాం. సో ఇక్కడ దెర్ ఇస్ నో క్లూ కాబట్టి జస్ట్ రైట్ ఇన్ టర్మ్స్ ఆఫ్ ఎక్స్ 1 minus x, 1 minus x, 3 plus x. సో ఇక్కడ ప్రోడక్ట్స్ కాబట్టి వీ హ్యావ్ టు యాడ్. సో 1 mole of x 1x, 1 mole of x, sorry 1 mole of I2 1x. Here 2 moles of Hi formed కాబట్టి వీ హ్యావ్ టు రైట్ 3 plus 2x. Okay, so first write in terms of moles, reactants lo minus chestam, product lo plus x chestam. Next add the number of multiply that x with the number of moles. So now we have to write the Kc. So given that so the clue is given that Kc for the reaction is 64. So just taking this plus 2x is only difference in this problem. So given that Kc is equal 64, so therefore we can write Kc equals 64 means HL square concentration square H2 concentration I2 concentration is 64 at equilibrium. So at equilibrium it is 1 minus x. It is also sorry. Products 3 plus 2x. 3 plus 2x whole square. But this is 1 minus ex and 1 minus x equals 64. So this square and it is also become square. It also we can write 8 square. So finally it become 3 plus 2x by 1 minus x is equal 6. Sorry. So here we remove the square and root 84 means there becomes 8. Next on calculation. So 8x. So now totally 10x equal becomes so 5 and x equal to so 1 by 2 is 0.5. So x equal to 0.5. So actually we have to calculate at last about the concentration equilibrium concentrations of a compound. Just x into manaki decrease in concentration in reactants, increase in concentration in products. But so therefore, what is the equilibrium concentration of I2? Therefore, at equilibrium, I2 concentration equal. I2 concentration was how much? Concentration, number of moles per liter. So 1 liter covered, it is no problem. So 1 minus x, so 1 minus 0.5, that is equal to, it's 0.5 moles per liter. Next, at equilibrium, it is also given in the question that to calculate the HA concentration. HA concentration also, concentration means number of moles per value. So value 1 liter kabatti no problem. 2 is totally 4. Okay, the 4 moles per liter. And we can calculate H2 concentration kuda exactly 1 minus x kada. So H2 concentration kuda 0.5 moles per liter avutadi. Okay. See, here 3 moles of PCl5, phosphorus pentachloride, kept in 1 liter closed vessel. Simple. But so it was allowed to attain equilibrium. We know the decomposition of PCl5 at 380 Kelvin. So calculate the composition of the mixture at equilibrium. If the Kc is given 1.8, so what is the composition means? Nothing but concentration of all compounds, the concentration of reactants and products at equilibrium. It is just like exact above problem model lone manaki. Okay. So but here it is given 3 moles initial, and there is no given about the products. Okay. So in the problem manaki products kuda 3 moles ichu. Ikkada only initial moles, initial ga reactant moles unnai, product moles are 0. So it is somewhat simple compared to that. So what is the reaction and the decomposition of PCl5 is a formation of phosphorus trichloride and chlorine gas. We know all are gases. We have to remember that. So what takes place at initial? So what are the initial 3 moles of PCl5 taken? So there is no products are formed. So at equilibrium condition, we know we have to write the general step. 3 minus x, here x and x. We have to find the 3 minus x, xx. So 1 mole 1x, 1 mole 1x, 1 mole 1x. So what is the Kc for it? So given that Kc is 1.8. So 1.8, we can write what is the step? 1.8 equal to the concentration of PCl. I am writing directly. So concentration of PCl3, concentration of Cl2, and the concentration of this one. So as it is given 1.8. So now here we can find the x simply. So that is x square. So that is 1 point. That is the 5.4 So this equation can be written as x square plus 1.8x minus 5.4 equals 0. So actually we had to find the x. So in the manaki simply x's cancel అయిపోయినాయి. So directly you got the x value. But here we got an equation. Okay. X square plus 1.8x minus 5.4. So we have to find the x. So here we need to get some mathematical knowledge. So already I think you better know about how to get the solution to an equation. So there is a formula. Just we write the formula. So what are the solutions for it? So what are the solutions for this equation? We can write so minus b plus or minus root b square minus 4ac by 2a. So you know this equation, and so here it is b, so c value 5.4, so a value is only 1. So after all this calculation, the overall this calculation we will get just one value I will substitute. For a value is only 1, so c value there is a minus 5.4, it's a c by 2 into 1. So on this simplification we will get x equal 1.59. So in these problems mainly, so in advanced model problems we will get this type of calculations. So now we got the x. So x వచ్చిnante we can find that equilibrium. What are the at equilibrium? So what is the concentration of PCl5? That was 3 minus x. 3 minus 1.59, so approximately 1. You can take 6. Okay, 1.41. 1.41 moles per liter. So our concentration kabatti, so by moles by liters తీసుకుంటాం. Like what is the concentration of PCl3? That was only x kada. So x kabatti it is exactly 1.59 moles per liter. Per liter is also 1. It's moles per liter. Same Cl2 also it is exactly x. So that is also 1.59. So means in that at equilibrium the concentration of PCl5 is 1.41 moles per liter. PCl3 concentration 1.59 exactly. Okay, because 1 mole into 1x kabatti. Same Cl2 also 1 mole kabatti its concentration also at equilibrium 1.59. Okay, see one more a different model problem. So acetone, this is called acetone, CH3COCH3. Its common name is acetone. So can you say about its IUPAC name? So which functional group is present here? It's a ketone functional group. So 1, 2, 3 carbons. At the second carbon ketone group is present. So it is treated as a propan-2-one. Propan-2-one or 2-propanone. Its common name is acetone. So acetone on decomposition forming ethane and CO. Here we must know all our gases. If initial pressure of acetone is 150 mm, so in terms of pressure is given at equilibrium. So and at equilibrium the mole fraction of CO is 1/3. So what is the value of Kp? So actually మనం Kp find out చేయాలంటే we have to get the partial pressures. So Kp find out చేయాలంటే partial pressures తెలవాలి. But here it is given only initial pressure. Initial pressure ఇచ్చుటూ అంటే మనకి partial pressures కూడా ఎక్కడ we have to find out the partial pressures at equilibrium. సో ముందు ఈక్విలిబ్రియం స్టేట్ తీసుకొచ్చి అక్కడ మనం partial pressures find out చేయాలి. ఓకే, సో ఫస్ట్ రైట్ ద ఈక్వేషన్. So very few problems are there based on Kp. So here initial pressure, it is given how much? It is given so pressure it is given 150. Okay. First we take in terms of moles. Okay. Total pressure here 150. So here important, so why we are not taking the initial pressure ఇక్కడ అంటే యాక్చువల్ మనం ఇక్కడ ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే మనకి నెంబర్ ఆఫ్ మోల్స్ ఫైండ్ అవుట్ చేయాలి బికాజ్ టు గెట్ ద పార్షియల్ ప్రెషర్. సో పార్షియల్ ప్రెషర్కి మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే మోల్ ఫ్రాక్షన్ ఇంటూ టోటల్ ప్రెషర్. మోల్ ఫ్రాక్షన్ ఇంటూ టోటల్ ప్రెషర్ ఫైండ్ అవుట్ చేయాలి. సో what is the mole fraction? First we have to find it. So mole fraction we will get okay, so let's take as a, so initial moles let's take as 1 0 0, and whatever at equilibrium, so simply it's 1 minus x x x. So what is the total number of moles? We know that what is the mole fraction? So mole fraction of any gas, mole fraction of any compound is equal to number of moles of that compound, the number of moles of that compound by total number of moles. Here total number of moles how much? So total number of moles equal to 1 minus x plus x plus x. So here it is total number of moles 1 plus x. So what is the mole fraction? So here the clue is given, the mole fraction of carbon monoxide is 1 by 3. So adhe carbon monoxide mole fraction in terms of x ikkada calculate chedam. In terms of x, mole fraction of CO is equal to its number of moles by total number of moles. So it is given how much? It is given 1 by 3. Okay. And here we can calculate about the x. So x value vachindante we are able to calculate all pressures. Okay. So therefore x by 1 plus x equal to 1 by 3. Here x equal to, so we got 0.5 or nothing but 1 by 2. Okay, so here x value ochindi, so x value tho manam we are able to calculate the other constant, so other mole fractions also. X equal to 0.5, so with the help of that we can write the mole fraction of acetone. Mole fraction of acetone equal its number of moles by total number of moles. So how many its number of moles? Its number of moles ఏముండే మనకి 1 minus x by total number of moles ఏముండే, that is 1 plus x. So that is a 1 minus 0.5. 0.5, so that's 1 by 5. So that is equal to 1 by 3. Means its mole fraction is again 1 by 3. Next, what is the mole fraction of, what is the one mole compound? Already for carbon monoxide we know that mole fraction of CO we got 1 by 3. So means now we got the mole fraction of 3 compound, just 1 by 3, 1 by 3, 1 by 3. Now substitute in the Kp. So normal గా, సో అన్ని ప్రాబ్లమ్స్ చేస్తుంటే మనం ఇనీషియల్ ప్రెషర్ 150 తీసుకొని మైనస్ ఎక్స్ ఎక్స్ చేయొచ్చు, బట్ హియర్ సపరేట్లీ ఇన్ఫర్మేషన్ గివెన్ అబౌట్ ద మోల్ ఫ్రాక్షన్. సో కాబట్టి ఇట్ బికమ్ ఈజీ టు క్యాలిక్యులేట్ ఇన్ టర్మ్స్ ఆఫ్ మోల్ ఫ్రాక్షన్. సో వాట్ ఈస్ ద కేపీ? కేపీ ఈజ్ ఈక్వల్ పార్షియల్ ప్రెషర్ ఆఫ్ carbon monoxide and partial pressure of ethane CH3 and partial pressure of acetone. Okay, So we know the partial pressure means mole fraction into total pressure. Mole fraction into pressure is given 150. Next 1 by 3 into 150. So all are having same mole fraction. We know that we have a formula according to Dalton's law. Partial pressure of a gas equal to its mole fraction into total pressure. Its mole fraction into total pressure. So you get a partial pressure of carbon monoxide equal its mole fraction into initial pressure 150. Okay. So here, so the Kp value is 50 millimeter. So in terms of millimeters it should, okay. So maximum in terms of atmospheres or bar listed, but in rare cases it is given mm. So 1 mm cancel, 1 mm is remained.